Hi team, Mr. Rator here. Okay, question 9, starting from Unit 11 and continue, with question 9. Okay, so this is talking about inverse proportionality. So first thing first is, let's write this question. T is inversely proportional to D squared. T is 160 when D is 8. Find the value of T when D is 0.5. Okay. First thing to set up is T, right? First of all, proportionality sign, as we stressed earlier, is this symbol. And when we say inversely, it's always 1 over. Okay, inversely is always 1 over. And what is it? Proportional to D squared. And we put the D squared. That's the first way to set it up. Secondly, you replace this proportional symbol for equal to. So T now becomes equal to. Now when we put equal to, we must introduce a constant k, which is being times this side. So when I times this by k, 1 times k is just k. It becomes k over d squared. Now this becomes our formula connecting t and d. Now before we can use this, we must work out what k is. And in the exam question, they will always give you values to work out what k is. So let's put these values in here. So t is, let's write it here, t is 160. We'll leave k there, and that is 160 when d is 8, so 8 is going to be squared. So 8 squared is 64, and therefore k is going to equal to, if this is 64, I'm taking that to the other side, I'm going to get 64 multiplied by 160. Okay, it's going to give us a pretty big number, therefore k is going to equal to, I can do 64 multiplied by 160, it's going to give me 10,240. That is the value of k. Now, once we've got that k, we can put it into our formula. So now we have a formula connecting t and d. So that's going to be k is 10,240 over d squared. Okay, so now it looks pretty big. It's going to be pretty big. So t, find the value of t when d equals 0.5. So t is going to equal 10,240 divided by 0.5 squared. Just plug that into your calculator. Divided by 0.5 squared. That's equals, you're going to get a large amount of 40,960. Okay. So this is inverse proportionality. Set it up first by putting your proportional sign and what it's inversely equal to. Then put the equal sign and change that one to a k. Then sub in your values that are given to work out the value of k. Then sub that value into this formula, so it connects and makes a formula relating t and d. Then when the question asks you, gives you certain values, sub those in and work out what the value of t is. Simple. Okay, let's just clear this and move down onto question 10. Okay, let's have a look at question 10. Now, diagram shows a solid triangular prism. The prism is made of metal. The density of the metal is 6.6 grams per centimeter cube. Calculate the mass. Okay, now the way I do this, first of all, I'm going to write what I say. Remember the triangle by remembering the word moved. So if I remember that word moved, it goes in that order: M, 9, V, 9, and D. Moved. Mass, volume, density. Okay. In this question, we've been given the density. So I've got D. I can work out the volume, and then from there, and then calculate the mass. Okay. Let's do the volume first. Now, to work out the volume, I need to work out the cross section. So this is a triangle, and the way we work out the area of the triangle is height times base is shared by 2, because it's half a rectangle. So I'll do 12 times 5 and share it by 2. And we'll call it CS because it stands for cross section. So the area of the cross section, 12 times 5 is 60. Half of 60 is 30 centimeter squared. So to get the volume of the prism, it's going to be cross section times the length. In this case, this is going to be times by the length, which is 15. The volume is going to equal to 30 centimeter squared times by the length, which is 15 centimeters. So the volume is going to equal, let's do 3 times 15, which is 45. Put the 0 there. So the volume is 450 centimeter cubed. So now we've worked out the volume. If I cover up the mass, mass is going to equal the volume, which is 450 centimeter cubed, times the density, which is given in the question, which is 6.6 grams per centimeter cube. So that means that each centimeter cube has a weight of 6.6 grams. The centimeter cubes are going to cancel in this form. They're going to just go. And if I put that into my calculator and type in 450 times 6.6, I'm going to get a weight, total weight of 2,970 grams. Now, you can leave that as your mass as 2,970 grams. Sometimes in questions, they want you to convert the grams into kilograms. You should know that 1 kilogram contains 1,000 grams. So therefore, if I divide this by 1,000, I'm going to get 2.97 kilograms. Notice the 0 will disappear here. That is the weight of this triangular solid prism. Okay, so let's make a note of that. Clear this. Let's have a stroll down. What is the next question? Okay, do this. Go on to the next one. Frustum. A frustum is made by removing a small cone from the large cone, as shown in the diagram. So this is the frustum. This shape here is more like a shade which is we use for a dining table or a light desk. Okay, so if you can imagine one of those desk lights, this is the shape we got. That's called a frustum. So we're removing this cone. So it says here, the frustum is made from glass. The glass has a density of 2.5 grams grams per centimeter cube. Work out the mass of the frustum. Give your answer, property accuracy. Okay, let's just have a go here. How we're gonna go about this. Now, 15. So what we need to work out what the mass is. Again, if we looked at moved, M, V, and D. So mass is equal to volume times density. We've been given the density, we can work out the volume, and then we can work out the mass of the frustum. Now before we do this, let's work out, it gives me the area of the full cone. So let's work out the area of the full cone first. So we'll put here full cone is going to equal, okay, so radius in this case is half this diameter, which is going to be 6. So, and the height of the full cone is 15. So let's just sub it in this equation. We've got 1/3 times pi. Pi is 3.142 in the calculator if you want to approximate it, and times the radius is 6 squared. Radius is 6, so we're going to square that, and then we'll multiply by the perpendicular height, which is 15. Okay. If we went on all in our calculator, we're going to get use your fraction by 1/3 times shift pi times 36 times 15. It's going to give me 180 pi. Okay, so now let's just take this smaller cone. So if that's 10 for the frustum here, and the smaller cone 10 take away from 15 is 5. Okay, that's 5, and we just need to know what the radius is here. Now what you should note is the cones are similar shapes. Okay, the cones are similar shapes. So that was 15 and that is 5, so that's 1/3 of that height. So we know that the radius is going to be 1/3 of 6. So if I go 6 times it by 1/3, I know that the radius here is going to be 2 centimeters. That is 6, that will be 2, as they are similar shapes, and therefore the size are proportional as well as the radius. Okay, so we got that. So now we've got the small cone. Small cone, if we do that, we'll get 1/3 times pi times the radius now is 2, so that's going to be 2 squared, and the perpendicular height is 5, the small cone. So put this in our calculator. Because that's going to give us an area of 20/3 pi. So that's the area of the full cone. This is the area of the small cone. To get the frustum, volume of frustum, therefore it's going to equal the larger cone 180 pi minus the smaller cone 20/3 pi, and that's going to equal end up with 520 over 3 pi, which is approximately, if I was to convert that, 544.54 centimeter cubed. Now, if we want the mass, we'll get the density, which is, well, we've got the volume, which is 544.54 times it by the density, which is 2.5. Now that is grams per centimeter cubed. This was already in centimeter cubed, so the centimeter cubes are going to cancel. So I've got my area. What the answer is, multiply that by 2.5. I'm going to get a mass of 1361.4 grams. 4 grams. I'm going to approximate that, so there's a proper degree of accuracy, so approximately equal to 1360 grams in kilograms. So we said before 1000 grams in a kilogram, that will be 1.36 kg kilogram.